we are going to talk about some basics of polynomials. This will maybe be a longer video. We need to get through about 4 pages of notes. Most of this should be review from an Algebra 1 standpoint, but we're going to talk about some terminology and then doing addition, subtraction, and multiplication with polynomials. So, a polynomial is the sum or difference of many monomials. Now, sum means to add, difference means to subtract, and we will get into the meaning of the word monomial in just a moment. The largest exponent of a polynomial is called the degree. So later on, we're going to be asked questions about the degree of the polynomial. And the way that we find this is by looking at which one is the largest exponent. So when we talk about standard form, we also talk about the fact that this is writing the exponents in decreasing order, which we will be practicing as well. The number in front of the largest exponent is always called the leading coefficient. And the sign of this leading coefficient, it tells us a lot about the graph of the function, which we'll get into a little bit more of. I think on the next page. Okay, so polynomials, they're classified by 2 things. They're classified by their degree and the number of terms. Now, when I talk about terms, this is things that are separated by pluses and minuses. And the degree, which we talked about up here, this piece right here, oops, is just the largest exponent. So if I have a degree of 0, this would be called a constant. And this would be something as simple as 2. That has no variable with it. It has no exponent with it. It's just a single number. We call that a constant. The next thing is a linear, which could be like x plus 2. This time it does have a variable. However, that variable is just an x. It doesn't have an x to the second. It doesn't have an x to the third. It's just an x. There's 1 in the exponent. Then we have a quadratic, which you just finished learning about, which an example of this would be like x squared plus 4. You'll notice that the degree here is that 2, right? That is the largest exponent there. Then we have a cubic, which could be like an x cubed plus x plus 3. The largest exponent there is a 3, so that 3 matches up with the cubic. Then we have a quartic, which would be an exponent to the 4th power. And lastly, we kind of stop at 5, and this is called a quintic polynomial. It has a quintic degree. So it has an exponent of 5. We'll go there. So those are the 6, I guess, main degrees that we talk about and refer to in this unit: a constant, a linear, a quadratic, a cubic, a quartic, and a quintic. And again, all we're looking at there is what is the largest exponent. Now let's talk about the number of terms. So this is the amount of things that are separated by pluses and minuses. So if there's only 1, that is a monomial. So this could be something like 2x. It's a monomial. There's only one term. There's nothing that has a plus or a minus around it. Then we talk about a binomial. Bi, meaning it has 2. So this could be like 2x plus 4. That has 2 terms. Then we have a trinomial. Tri meaning 3. So this could be something like 3x cubed plus 2x plus 4. And lastly, we have a polynomial. So anything 4 or greater, we refer to as a polynomial. So this would be like 2x cubed plus 3x squared plus x plus 4. There are 4 terms there. 4 things that are being separated by pluses and minuses. 1, 2, 3, 4. All right, so I'm going to do 3 examples with you, and we are going to go through, I'm going to do the highlighted ones, so 1, 3, and 5. We're going to state the degree, the number of terms, as well as the leading coefficient here. So, for number 1, the degree. In this case, I'm looking for what is, I'm looking for, is there an exponent attached to that x? And there isn't. So this has a degree of 1, making it linear. When we talk about the number of terms, there is 1 term, 2 terms. So that means this is a binomial. And lastly, when we talk about the leading coefficient, I'm going to use LC for short. That is the number that is in front of wherever we got our degree from. So that would be this -3 here. It's not just the number, it's also the sign that goes with it. So since there's a negative in front of that 3, we say -3 is the leading coefficient. Number 3, degree, number of terms, and the leading coefficient. So this has no variable. That means if you look at your chart that we already created, a degree with no variable is a constant. And then the number of terms, there is only 1 term here, so this is a monomial. And lastly, the leading coefficient is 24, the only thing that is there. All right, last one we're going to do together is this number 5 here. So degree, the number of terms, the leading coefficient. The degree here, my largest exponent is right here, and that is a 2, which makes this a quadratic. My number of terms, there is 1, 2, 3 things separated by pluses and minuses, which makes this a trinomial. And the number in front of my leading degree is a -1. So I did 1, 3, and 5. You will be expected to do 2, 4, and 6. Once you finish those, I would pause the video, do 2, 4, and 6, and then continue on. So this next section, we are going to talk about even versus odd functions. So we're going to start with an even function. An even function will have an even degree. Therefore, if I talk about an odd function will have an odd degree. Okay? Then we need to kind of discuss what this word end behavior is. So end behavior refers to what is happening to the function when we look at either negative infinity or positive infinity on the x-axis. So this little chart down here, we're going to build our own little chart to tell us about the end behavior of even and odd functions. And more specifically, you'll notice that I've got an even degree and an odd degree. But then I've also got this other section of the chart where we have a positive leading coefficient versus a negative leading coefficient. So when we talk about an even degree, even functions, they go the same direction on the ends. And this may not make a lot of sense right now, but when we start to do some practice problems, I will show you what the graphs of them look like, and we'll talk about the way that they're shaped and how one side goes up, one side goes down, or they both go up, or whatever. So for an even degree with a positive leading coefficient, both sides are going to go up. So at negative infinity on the x-axis, the function is going to go up. At positive infinity on the x-axis, the function is going to go up. Now, if I have an odd degree with a positive leading coefficient, these guys go in opposite directions. So the left side is going to go down, the right side is going to go up. So at negative infinity, it's going to go down, and at positive infinity, it's going to go up. So then when we have positive versus negative, I did all the positives, now I'm going to do all the negatives. And they just switch from what they are. So instead of both ends going up, both ends go down if it is even in negative. And instead of going down and then up, they go up and then down if the coefficient is negative for an odd function. So something that I always like to keep in mind is that if it's an even degree, they're going the same direction. And if it's an odd degree, they're going opposite directions. Okay, so we're going to graph these functions below. We're going to determine the sign of the leading coefficient, whether it's even or odd, and then we're also going to talk about the end behavior. So before I even graph it, I can figure out whether it's even or odd and whether it's positive or negative. So looking at this function, the degree here is whatever my largest exponent is. So that's a 4. And my leading coefficient is the number in front of that, which is also a positive 4. So in this case, I have an even positive polynomial. So let's look at what the graph of this is going to look like. So y equals 4x to the 4th plus 6x cubed minus x. So if I'm looking at this graph, do you see how both sides are shooting up towards the sky, right? This is an even function. It is positive, so both sides are going to go up on the ends, right? So what I can say, I'm going to just draw a little sketch of this graph here. The graph for this function looked a little something like this, right? So what I can say is as x approaches infinity, I want to know what is my function doing. So what this means is as my x values are going this direction, right? So as my x's are getting bigger, what is the function doing? Is the function going up or is the function going down? In this case, it's going up towards positive infinity. And then I do the same thing for the other side. As x approaches negative infinity, what is my function doing? Well, negative infinity goes this way. So as my x's get smaller, is my function going up or is my function coming down? And again, in this case, it's going up. This is what I mean by the end behavior. And yes, you will have to write as x, whatever, as f of x does this, as x does this, f of x does this. So what you should have noticed is that here I have an even positive, and this is what my ends did. Right? At negative infinity, it went towards positive infinity. At positive infinity, it went towards negative infinity. Let's do another one. Number 3 here. Here's my degree. Here's my leading coefficient. In this case, I have an odd degree. Whoa. With a positive leading coefficient. So based on my chart, the ends of my graph should do this. So we're going to check ourselves. We're going to look at 2x cubed. So here's my graph. I'll draw a rough sketch of that graph here. So in this case, I'm going to say as x approaches infinity, what is f of x doing? Well, it's going up. And as x approaches negative infinity, the function is doing what? Well, it's going down. All right, the very last one that we're going to talk about is number 5 here. So here's my degree. Here is my leading coefficient. I have an even degree with a -2 as my leading coefficient. So I have a negative leading coefficient. So with that in mind, even negative, it should look like this. So let's check ourselves. So we're going to do -2x squared plus 4x minus 7. And it looks like this is going down on both sides. So it does look like my chart. So again, it looks something like this. I'll draw a little rough sketch. You don't have to do this. I'm just doing this because I don't have the graph in front of me at all times here. So as x approaches infinity, so as x goes this way, my function is going down. So f of x approaches negative infinity. And the other side, as x approaches negative infinity, what is my function doing? Well, negative infinity goes this direction. My function is also going down. So I'm actually going to stop the video there, and I want you all to try 2, 4, and 6 on your own.